Hi, I'm with the dollar-based SOAR team, and I'm here to test the robots out on the docks.
Okay, sounds good. Just give me 1 second, please.
I always be your captain.
Before there was our marine robotics elective, we taught a class called Science Applications, which was sort of a funny name because it was a textbook class. It was a tough class to teach because the students didn't want to take it and the teachers didn't want to teach it because there was no passion on either end. So we had an opportunity to get some exploration and learn how to build a simple underwater robot that could be used to explore.
Matt and I were partners in a workshop basically and built the first remotely operated vehicle and brought it back here. And the idea was for Matt was going to start an enterprise program here.
The idea was then, if I had that first experience, I could then start getting my students, my kids that maybe aren't sure what they want to do, a chance to just explore and really get their hands into that, investigating something that's never been seen before.
I'm going to tech next year for electrical engineering, and I almost guarantee I would not be doing that if it wasn't for this class. It's more of a student-run class, you know, so he's not always showing us exactly what to do, or he doesn't give his opinion all the time. And I think that's good because it allows us to fail.
If it didn't work, I didn't give up. I kept going, and that's because that's what SOAR taught me to do. If it fails, well, learn from it. You have to learn from it. You have to move on and fix it.
It's just that I had so much freedom to take things and do what I thought was necessary. I would run it past Mr. Zimmer, but he was really there for me making the decisions, for me to grow through this experience.
If there's something we've never done before, a lot of the times we look it up on the internet, we see what other people have done and we try to make improvements.
You were kind of teaching yourself and learning as you went, and you had other people helping you. It was definitely the best way I've ever learned.
We'll ask him, oh, is this a good idea? And he'll say, I don't know, try it. So that's really how he is with SOAR.
The marine robotics, the SOAR program, is essential to dollar-based school. People on the outside have heard of us because they've heard of this amazing program where kids are solving problems for people out there, for agencies, for universities, for Isle Royale National Park. It's put us on the map in a lot of ways, and it's really the students' work and the teachers' work that has made that happen.
So I'm taking the skills that I learned from SOAR and implementing them into my professional job that I have this summer, which is very exciting.
In other classes, you always wonder if you're going to use that material, but with SOAR, you know you're going to use it in the real world.
So there's 2 levels, there's rookie and veteran, and so you're a rookie and your first task is you have to develop an ROV and it has to retrieve a T that's underwater.
This is the very first time we call them rookies. This is their first time through this really design, revision, explore project. Then when they repeat the class, which is something you can repeat and you amp it up to the next level, you found out really how limited your first design is and how to make it better to go deeper, farther, last longer, bring you better video, or manipulate something below the surface of the water. The veteran members, as they return, choose really a specialty area, whether they want to work in additive manufacturing or explore circuits or explore video, many different aspects, whatever they really are kind of interested in or wanting to improve, they start to focus on that end of the high-tech ROVs, and they specialize in that. And then they take these ROVs and work with the entire team to develop a product that's beyond what any of them could come up with on their own.
Maybe we could add something like in the, I don't know. Because if we add something,
yeah, but when it goes backwards, I think the reason that it goes like that is because we don't have noodles in the bottom at all.
Yeah, but we don't want the bottom to float.
Yeah, but
it's problem solving where the problems are no longer made up by the teacher. The instructor, the teacher, hasn't removed the nuances, the tricky things, the hang-ups. all the ugliness stays with the problem as you work it through. And that also what makes it so much more exciting. The answer is, I think this, and I'm going to make it and find out if it really is that.
Yeah. It goes like this, and then it goes like that.
Push on it like it's going to go backwards. Push on your robot from where your motors are to where it's going to go backwards. Where are your motors located?
In the bottom.
In the bottom. So the water's pushing here, 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 here. Whereas you only push the other way.
Okay.
The student, for the first time, is exploring something where the answer that the student works to come up with can only be checked by implementing that answer. How would you remedy that problem? When I look at how we actually conduct the learning that happens in the classroom, we put this challenge forth and the students choose to engage in this challenge with, like I said, the ugliness that goes with the problem. We didn't pull out the tricky things we might think would be too hard for the kids. And so as they start to come up with a solution and they think they have the answer and they're sure it works, they now put it in the water. They take their main idea, their answer, and they throw it in the water and it doesn't work. It fails, it leaks, it explodes, it burns up, and they have to try it again. They made this huge mistake and they're momentarily devastated. But with that devastation comes a spark where I think I know how to fix this. And that drives their learning, and that's what drives them to the final solution that really does solve their challenge. There's the other end of our organization that involves the media. So we, as an enterprise program, our product to the public seems to be these robots. Well, if we're a business, we need to be marketing our product to the public, letting the community know that we can solve their problems if they exist below the surface of the water. We are ones that find technical solutions to your water-related problems. So the students have their Facebook site that's marketing public, parents, anybody who might have a use for these underwater ROVs. They maintain an Instagram site to recruit new members into their program. And they have blogs which specialize in very specific areas to assist maybe other high school teams doing the same thing. So you have this entire language, arts, and technical communication that wrap up with the actual engineering and manufacturing of these products.
We started designing a logo that year, and we worked with Monty Consulting for a little bit of guidance because we had no idea what we were doing. Did a lot of sitting down and thinking about like what SOAR meant to us, what SOAR meant to the group.
I remember one of their first ideas was incorporating the team name SOAR into a water droplet. And when they kind of brought it in for one of their ideas, they were looked at and said, yeah, that works. I see what you're doing with water. That's kind of sea level work. And it was just looking at them going, whoa, it's not that great. And they got to learn how much more really needs to go into a logo.
So we ended up actually going with sign language. There's an O that looks like this. It's got two lines going through it, and that means to preserve. So we kind of put a little subtle part of what we felt SOAR was into that logo. I'm not sure it always gets across, but it's important to the team, and I like that.
One of the neat aspects I've started to hear in talking with parents that have students enrolled in this project is it becomes almost an icebreaker between child and parent, where now they have something they can talk about what they did in school. And sometimes they take home a little piece of the project they're working on because they can't describe it verbally, but they're taking home a small circuit board. They're taking home a small printed part or something they machined and saying, this is part of the team project I'm working on, and I've created this. And the parents are excited because their child is talking to them again.
She comes home and says, Mom, I know how to code. I understand it. I worked on my own today. My partner was off on another program and was out of class, and I milled something all by myself from scratch. I am just so thankful that she's had this experience and is having this experience and is compelled to go into women in engineering for the first time this summer for Institute. So it's all good.
I've had a number of kids in this program. In fact, I'm working on number 6 right now. The oldest one, Carl, down in Copper Harbor with a local contractor, and he had, one of the pieces of equipment broke. He was able to get in there and figure out it was a relay problem and change it out and get the machine back up and running. My second oldest, my daughter, I came home one day and she's in there soldering wires in her car, to get her window to work in her door. And I'm like, well, hey, how'd you learn that? Oh, I learned that in robotics. The next one down, Lance, they give all these presentations, The word there was, man, he really gave a good presentation. He understands it and he's able to communicate it. And well, guess what? He's a salesman now, So, yeah, they just get the confidence and the exposure to it, right? That's no big deal. I can do that, or it's huge.
What we do is you put a little bit of... By being in the enterprise, the students have a chance to try something like soldering and realize, well, if I break it, there's going to be a chance to fix it and make it better. Put the risk out there and try and see if they can fix the problem before they go to somebody else.
We are making a camera. Waterproof, so it can go on the rookies' ROVs. We've been ordering fish finder cameras, but they keep breaking, and so they're not lasting very long and they're more expensive.
Hey Aubrey, what did you learn yesterday about cameras?
That you should look up how much volts they can take before you plug them into a battery.
So the students know there's certain pieces that they need, but they might need to customize those pieces to make them, to achieve the task the client sets beforehand. And a really neat example of what the students have done is with their rookie ROVs, they use a 1/2-inch pipe PVC frame. Their newest ROVs, it's sort of like what happened in the automotive industry where cars used to have frames, and now they moved to a unibody where the body of the car is also the frame. Students have done the same thing with their ROV. They used to have frames. Now they're using 3D printing to kind of make the whole thing one body and frame all as one part. So there's not a basic frame to mount stuff to. What really has set their ROVs apart and moved us beyond what we had is the opportunity to do 3D printing. Before this, you would find something at a hardware store that might be kind of what you want and cut away or add to it until it became close to what was in your mind. With 3D printing, my students have the opportunity to bring out exactly what's in their mind and have it created before them. They are student-built printers and they are student-maintained printers. The students control every aspect of them as far as the maintenance, and when something does break, they are also expected to find where has the problem happened, what do they need to do to repair it, and then execute that repair.
A lot of times they'll jam or the arms will fall off, and we know how to stop it and reset it and get it going again and calibrate them so they stop falling apart.
If they make a repair, they're not done, but they need to now test it to make sure it does work right. The students own that equipment. It's their materials to use. It's their material to, well, break, but then also repair. SOAR originally was an acronym for Student Organization of Aquatic Robotics. Well, we've done work for universities that had nothing to do with robots. We just needed to make waterproof devices. We've done work for local companies that didn't have to do with underwater, but they were produced objects. So they've moved from becoming strictly underwater work to SOAR, the enterprise that solves technical problems. One of our partnerships involves working with a company that used to have to import from Italy part of their robotic systems when it broke.
Right now they are actually the sole supplier of that part for us. In essence, the SOARS team has become our research and development prototype group, if you will. We've had several instances where we had problems with equipment and didn't have a real solution other than looking at a 3D printed part to do it, and it solved several problems for us then.